Good afternoon, sir. Today I am going to present on fractional distillation topic. Now let's start. First of all, I have to talk about what is fractional distillation. Fractional distillation is the process of separating crude oil into lot more totally different and much more useful organic hydrocarbon products based on their relative molecular weights or relative volatility in a distillation tower called fractional distillation. It is called fractional distillation because we get different products called fractions at different levels of this tower based on the relative volatilities. This is the preliminary step in the processing of raw crude oil, and it is considered to be the most important separation process in the industry as it performs the initial rough separation and gives us the different fuels. The different fuels, also called fractions, are separated out including different compositions of petrol, diesel, kerosene, and bitumen. Now, moving forward, I have to talk about the crude oil. Now, first of all, we should know what is crude oil. Crude oil is a mixture of hydrocarbons that exists in liquid phase in natural underground reservoirs and remains liquid at atmospheric pressures after passing through surface separating facilities. Depending upon the characteristics of the crude stream, it may also include some of the followings. Small amounts of non-hydrocarbons such as sulfur, phosphorus, and other metals, or drip gases and liquid hydrocarbons produced from the tar sands, or oil shales. Now we will talk about distillation process. Distillation is the process of separating the components or substances from a liquid mixture by selective boiling and condensation. By selective boiling, we mean the partial boiling and condensation of the products and the reactants that we feed in the, or a feed mixture that we feed in the distillation column. And fractional distillation. Now, fractional distillation is the breaking down of mixture into its component parts. This is done by boiling the mixture and separating the products by their varying boiling points. In simple distillation, we take out the product only at the top and the bottom, while in fractional distillation, we take out the products from the various stages inside the column. Now we will talk more about fractional distillation. Fractional distillation is the most common form of separation technologies used in petroleum refineries, petrochemical, and chemical plants. New feed is always being added to the distillation column and products are always being removed. Unless the process is disturbed due to change in feed, heat, or temperature, or condensing, the amount of feed being added or the amount of product being removed are normally equal. Unless the process is disturbed by the change in feed, heat, or temperature, condensers, the amount of feed being added and the amount of product being removed are equal. This is known as continuous steady state fractional distillation. Industrial distillation is typically performed in large vertical cylindrical columns known as distillation or fractionating towers, or commonly known as distillation columns, whose diameter range from about 0.65 to 6 meters, that is to 2 to 20 feet, and heights from 6 to 60 meters, that is 20 to 197 feet, or it may be more also. The distillation towers have liquid outlets at intervals set up the column which allow for the withdrawal of different fractions or products, having different boiling points or boiling ranges. By increasing the temperature of the product inside the column, the different products are separated. The lightest product, that are with the lowest boiling point, exit from the top of the column, and the heaviest products, those with the highest boiling points, exit from the bottom of the column. Large-scale industrial towers use reflux to achieve a more complete separation of products. Reflux means the portion of the condensed overhead liquid product from distillation tower is returned to the upper part of the tower. This is only done to increase the separation and to increase the yield of the products. Inside the tower, the reflux fluid flows downward, provides the cooling needed to condense the vapors flowing upwards, thereby increasing the effectiveness of the distillation tower. Otherwise, it was only cooled because of the heat transfer within the tower and the atmosphere. But now the cooling also occurs due to the refluxed liquid. Therefore, the more the reflux is provided for a given number of theoretical plates, the better the tower separation of lower boiling materials from higher boiling materials. Alternately, we can say the more reflux provided for a given desired separation, the fewer plates are required. Now we will talk about the principle on which the fractional distillation is based. From the operational point of view, the fractional distillation is a mass transfer process involving countercurrent diffusion of the components at each equilibrium state. Countercurrent because the vapors flow upward while the liquid flow downwards. Therefore, it is countercurrent. When a liquid mixture is distilled, the partial condensation of the vapor is allowed to occur in a fractionating column. In the column, the ascending vapors from the still is allowed to come in contact with the condensing vapors, returning to the still. This results in enrichment of the vapors with a more volatile component. By condensing the vapor and reheating the liquid repeatedly, the equilibrium between the vapor and liquid is set up at each stage, which ultimately results in the separation of a more volatile component. Now, this is a crisp of fractional distillation. Uh, in fractional distillation, the mixture is separated by boiling and collecting each substance as it boils. Each substance is called a fraction. This is a mixture of hydrocarbons of similar chain lengths. As they are of similar chain lengths, they have similar properties and therefore they boil at a similar temperature. Now, these are the stages in a fractional distillation column. First of all, the crude oil is heated in a furnace. A mixture of both liquid and vapor are passed into the tower that is cooler at the top than at the bottom. The vapors pass up this tower in which these are trays stacked at different levels, and these trays contains bubble caps to trap the vapors. As the vapor rises and it gets cooler, once sufficiently cool, the vapor will condense into liquid and will therefore be collected on the tray below. The shorter chain hydrocarbons condense in the trays nearer to the top of the tower, and while the longer chain hydrocarbons condense in the trays nearer to the bottom of the tower. This occurs as they have lower boiling points and respectively higher boiling points, and therefore the liquids in lower temperature and higher temperature. Now this is a schematic of fractional distillation column illustrating the products that we get from the fractionating tower. As we can see, the crude oil is preheated in a heater or a furnace and then put it inside the fractionating tower. The main product, the most important product, are the refinery gases and petrol, which are used directly as fuels. While we get some other products also like kerosene, diesel, lubricating oil and fuel oil. The bottom residue that is left at last of the fractionating tower is used to make bitumen, asphalt that is used in the construction of roads. While naphtha can be even naphtha, which is the lighter products than petrol and lighter than kerosene, heavier than petrol, is used to make various chemicals. While kerosene is another fuel which is very useful. Next, these are the applications of the fractional distillation. Fractional distillation is used for separation of miscible liquids such as acetone and water, chloroform and benzene. These can be easily separated using fractional distillation. Preparation, or we can prepare alcohols, which is one of the most important pharmaceutical substance. Fractional distillation is used in the manufacturing of alcohol also. Separation of non-volatile substance from volatile substance. For example, preparation of distilled water for injections. We can separate out the non-volatile substance from volatile substance. If water is less volatile, therefore it boils at 100 degrees Celsius. We will increase the temperature to 105 degrees Celsius and wait for the water to boil and collect the water in the upper region. Purification of many organic compounds such as ethers, amides, etc. Now this is the difference between simple and fractional distillation. In simple distillation, vapor is directly passed through the condenser, whereas in fractional distillation, the vapor must pass through a fractionating column in which partial condensation of vapor is allowed to occur. In simple distillation, condensate is collected directly into the reservoir, while in fractional distillation, condensation takes place in the fractionating column, so that a part of condensing vapor returns to the still, the same as the reflux. This is a schematic showing the difference between the simple and fractional distillation. On the left hand side, we can see simple distillation, while on the right hand side, it is a schematic of fractional distillation, in which a fractionating column is used. This is a laboratory This is laboratory setup of the fractionating and simple distillation. Now, advantages of fractional distillation. Fractional distillation is extremely easy to use and readily purifies complex mixtures. Separate liquid with smaller boiling point separations. But with advantages come disadvantages also. It cannot be used to separate miscible liquids which form azeotropic mixtures and this consumes more energy. This setup is very costly and complicated and also takes longer time for liquids to distill. These are the references I have taken to prepare this PPT and for the all of the material that I have shown you. Thank you.